In this next example, we're going to look at the Gaussian rationals, and the fact that the Gaussian rationals are going to be, well, they're going to be a subring and a subfield of C. But what's going to happen is we're basically, just by allowing our real and imaginary part to be rational now, we're going to fix the division issue. Okay, so before, in the previous example, we didn't have things like the multiplicative inverse for 2. We fixed that problem, and basically what's going to happen. So let me state the claim first. Q adjoin I that's how this is pronounced. So Q adjoin I is a subfield, hence also a subring of C, and in fact Q adjoin I, the Gaussian rationals, and the Gaussian integers are related through an algebraic process called taking the field of fractions. So this is what's sometimes people write frac. This is frac Z adjoin I, which is the field of fractions. So there's this controlled process of taking a domain, which Z adjoin I is. It's a ring without zero divisors. All subrings of C are domains. And producing a field from it in a natural way. Namely, there's lots of different ways of producing a field. I could choose to produce the field C from Z adjoin I, but that's somehow not natural. We sort of relied on the fact that Z adjoin I was a subset of C to do that, or at least some like connection there. But there's a natural way of producing a field from a domain called taking the field of fractions. And when you do that to the example we did in the previous video, you get the Gaussian rationals. Okay, that's not relevant for this example, but there is some algebra going on in the background. Okay, nevertheless, Q adjoin I is a subfield of C. We use the subfield test. When you write your proofs, make sure you tell the reader what you're going to do, and it'll help focus what you need to do and make your proofs easier to read. Not that my proofs are easy to read. We use the subfield test. All right, so we need to show that 1 is there. We need to show we're closed under subtraction, and we need to show we're closed under division. Well, 1 plus 0i is certainly there, because 1 and 0 are rationals. Great. Closed under subtraction is exactly the same as before. Take a minute, pause, do it. Closed under division is new, so we have to add that in there. Okay, suppose A1, we're using P's and Q's, P1 plus Q1i and P2 plus Q2i is in Q adjoin I. We need to show P1 plus Q1i, times P2 plus Q2i inverse is here. All right, that's what it means to be closed under division. Now, we had a formula for the multiplicative inverse of a complex number. And that formula was take the real part, divide by the modulus squared, the sum of the squareds of the real and imaginary part, and subtract off the change the complex number to its conjugate, and then divide by the modulus squared. I'm going to say it that way. Okay, so that was our formula for the inverse. And let's just take a moment and notice that, let's say for P2 plus Q2i not 0, as long as P2 plus Q2i is not 0, this is well defined. And furthermore, the real and imaginary part here these are rational numbers because it's just rational number squared plus rational number squared, which is rational, and then rational divided by rational. So the real and imaginary parts are certainly rational. And now if we do this product, we get the product of the real parts, yuck, minus product of the imaginary parts, yuck. The imaginary part here is negative. Keep that in mind. It's not positive, it's negative. Plus the product of the cross terms, sorry, the sum of the cross terms. Writing and talking is difficult. So that's one of the cross terms, and this is another one. Oh, by the way, I'm going to make plenty of mistakes. Feel free to point them out when I make them. Now the point is here is that this whole thing is rational. This whole thing is rational. And so therefore, the whole thing is rational plus rational I, and that's all it means to be a Gaussian rational. Implies the division is again a Gaussian rational. This is a very important example. You should know how to do this example sleeping. You should know how to apply the subfield test and the subring test while you are asleep. That's how important it is. Okay. All right. So by the subfield test, we're done. Q adjoin I is a subfield and hence a subring also of C.